Hey guys, so this is a review, a summary of all three trends that we worked on. Remember, if you have all of your bell ringers and your notes and then the summary worksheet, you can use it on the quiz. Okay, day one, when we talked about atomic radius, we did a bell ringer and a notes sheet, front back. Second day, we did ionization energy, bell ringer, notes. Day three, when we did ionic size and electronegativity, we just did notes. And then the next day, we have this summary sheet. Okay, so on this Google Classroom assignment, I have all of her videos on atomic or on periodic trends posted, so you can watch them or you can watch this summary video. I have another summary video after this one that was maybe last year's when we didn't do this summary sheet, so you can stop with this one or watch the next one too. Okay, so ready? Here's our first question, and it's asking us, using the periodic table below, to label the electron configuration trend. Okay. So I am going to, okay, I guess it's going to stay right here. Okay, you may have to get out your highlighted periodic tables, or you may remember how to figure this out. Now this is going to be next year's. I feel like this year they didn't label it that clearly. So remember, we have our groups across the top, periods across the bottom. You will have to know that for your quiz. Okay, so we have groups 1 through 18. And we can actually break this up into our SPDF blocks. So remember, we learned that here is the S block. Helium is over there because based on its periodic trends, it fits in with the noble gases. It has a full outer valence electron level. Okay, but technically it fits here. I'm going to use a different color and highlight our P block. I'm going to use a different color, highlight our D block. And I'm going to use the fourth color and highlight our F block. And so remember what we learned day one of the periodic trends is that we see trends going down the groups where everything in the same group has similar properties or characteristics, shares the number of valence electrons, which give them similar properties and characteristics. But across the periods, the only thing we could say that are similar is they share similar energy levels. They'll both be in a certain S block or P block or D block or F block. Okay, so if we had to label these, and the periods are 1, 2, 3, 4, 5, 6. Ready? We have 1s1. Helium over here would be 1s2. 2s1, 2s2. Okay, we're going over. Remember, we're reading it. We hit the P block. So P block starts at 2. That means 3, 4, 5, 6. Okay, 2p1. 2p2, 2p3, 2p4, 2p5, 2p6. Remember, P's have 6. 3 orbitals, 2 electrons each, 6 total electrons. Okay, next one. 3s1, 3s2. Okay, 3p1. Now I'm not going to fill out all these because it's the same thing. 3p2, 3p3, all the way to 3p6. Okay, come over here, 4s1, 4s2. Okay, now, it's not 4d. D's start out 3, okay? So S's start out 1, 2, 3, 4. 3d1, 3d2, all the way up to 3d10. Okay? Then we're over here, 4p1, 4p2, all the way up to 4p6. Go to the next one, 5s1, 5s2. Okay, 3d was here, so now it's 4d1 all the way to 4D10. Now we're at 5P1, 5P2, 5P3, all up to 5P6. Okay, 6S1, 6S2, 3, 4, 5D1, all the way to 5D10, 6P1, all the way to 6P6, and then we're starting with our Fs. Remember, first, so 1S, second, 2P, third, 3D, 4, 4F. 4F1, all the way to 14. 4F14. 5F1, all the way to 5F14. So that was a good review of the periodic table and its electronic energy levels. And I could even just say, hey, which element has its last valence electron at, I could say 4p6, and you would know which one it is. Okay, so we label that for number 1. Now let's talk about the trends. I'm gonna put all 3 trends on the screen at one time. That way we could compare and contrast. Okay, so I'm gonna put the snowman in the middle. That way we could talk about the trend going downward and the trend going over. Okay, so we have our first trend, which was atomic radius. Okay, then we have ionization, then we have electronegativity. Okay, so I'm gonna draw them, then we'll explain. So remember, you were asked to draw the summary and explain why, okay? So our first one. Okay, next one. Ooh. Okay, this first one is regular snowman kicked over. So let's talk about the atomic size. Okay, going down, the size is gonna increase. I'm gonna put I for increase because you're getting more energy levels. So ready over here, I'm gonna say increase because, so this is talking about the size, more energy levels. Remember, your energy levels are those track lanes, and as you have to fill them out, those track lanes can't compress that much because of the shielding effect. Okay, so you are spreading them out. Okay, now we learned over here, so remember, over here on the periodic table, you may have lithium with 3 protons, and over here you're gonna have neon with 10, even though technically that's 10 protons and 10 electrons, and it seems like you have more subatomic particles. You have more of a charge in the positive nucleus, therefore it's attracting the electrons more, sucking them in. Okay, so technically you decrease over here because electrons are more attracted to positive nucleus, okay? Okay, next one, ionization. So remember, going into this quiz, you have to know what an ion is, a cation, and an anion, and how to make them, okay? When you give away a negative electron, you give a negative, so you become more positive, okay? You are a cation. Also, you are lighter. We talked about size in the 3rd unit. Okay, when you take and steal a negative electron, you become more negative. So you're more negative, you're actually a little bit heavier. Your mass is a little bit greater. Okay, so to become an ion, let's talk about it. Okay. Now, this one's a little bit harder. Okay. Down here, where these atoms are very big, have a lot of energy levels, those electrons are further away from the nucleus. It's actually pretty easy to steal an electron. So guys, you do not need that much energy. So this smaller part of the snowman means you don't need that much energy. So as you go down the periodic table, you decrease the amount of energy needed to steal an electron because they're so spread out, okay? When you're up here and the atoms are smaller, their electrons are closer to the nucleus, and remember, picture the nucleus like the mama. The electrons that are closer to the nucleus, they're harder to steal. They're being more watched and they're attracted to that mama nucleus, okay? So you need a lot of energy to steal here, a little energy to steal here. Okay, then up here, we talked about it. These electrons over here are pulled in. The size is even decreased because they're attracted to that nucleus. So you need a lot of energy to steal anything from this side of the periodic table. So this is the increased trend, okay? And that's because you need a lot of energy to steal from something that's being held so close to the nucleus. Okay, so ready? We decrease down this way because as you go down periodic table, atoms have more, I'm going to summarize it, energy levels, EL, energy levels. So easier to steal because they're farther away in their further energy levels. You have to increase energy going this way because electrons are held tight to nucleus, which is exactly what we talked about here, okay? Last one is electronegativity, okay? Electronegative. How do we become negative? We steal electrons, we become an anion. So it's talking about who's gonna steal, who wants to become an anion. It is, when we go up here to our periodic table, it was fluorine right here. So fluorine, I'm gonna put an F right here. Fluorine, we learned about, was the most electronegative. Y'all, the noble gases that are right here on the periodic table, they're already happy. They already have a full outer valence electron. They have full outer valence electron. So they don't need to steal. But this, the halogens, number 17, especially fluorine, they have 7 valence electrons. All they have to do is steal one more. So they want to steal really bad. So as you go over here, you see the electronegativity increases because they are almost full and want to steal more. So they have this intrinsic want to steal. I'm almost full, I'm gonna steal it. Whereas, let's just say group 15 with 5 valence electrons, you know, they're like, I can give away 5 or steal 3, what should I do? The halogens that have 17 know they need to steal 1. Okay, as you go down, the electronegativity decreases because more energy levels, it's bigger. Okay, and then remember the last thing we learned on the third day of trends was ionic size. So remember, cations, which are positive, are smaller because they gave away an electron. Anions, which are negative, are larger because they stole an electron, okay? So I could ask you guys, aluminum and sulfur, which one is more electronegative? You turn to that page of notes, figure out the trends, tell me which one. Aluminum, sulfur, which one has the smallest atomic radius, okay? So there might be a whole bunch of questions where I just give you two elements and you tell me which one. It's a lot like day 2 bell ringer, okay?